So, um, my name is Tomer. I work for an Israeli company called Wix, but that is not the point. What is the point is, this is kind of an unusual talk for me. My talks usually tend to be more technical and in-depth. This time around, I figured that I'll try and take a sobered up look at the Scala ecosystem and sort of try to point out a few of the things that I consistently see having been in this community and working with Scala in production for about 6 years. So just to get started, who here actually knows what these words mean? All right, that's actually about half the crowd. It's more than I expected. Cool. For everyone else, and also to make a point, let's take a quick look at kind of a dictionary definition of what bifurcation means. So looking at Wiktionary, you can see that bifurcation in biology, in geography, and in a whole bunch of other fields essentially translates to a group or a thing being divided into two. Two separate branches, two separate concerns, and the synonyms for that actually very much reflect that. So you have branching and you have forking, but what I want to point out is that there's no connotation here, right? It's not a positive or a negative thing. It's just an observation, it's a fact, right? If something is divided into two, it's bifurcated. There's nothing inherently problematic about that. Schism, on the other hand, assuming I'm pronouncing the word right, because I'm not a native speaker either, schism is a split or separation within a group or organization, and I want to highlight that last bit because it is typically caused by discord. That is one of the definitions. So synonyms for that would be division, separation, split. I've also seen rift. So these are a little bit scary, right? These are kind of negative words. Also, if you look at what the antonym for schism is, it's unity. So basically, schism is the opposite of unity, and that's really bad in any community, and certainly in the software communities. So, tying this to Scala, if we take a look at some representative libraries within the Scala ecosystem, you have your Akka and you have Spex2. For those of you who haven't seen this before, this is Shapeless. We also have Cats, and we have Monix, and a whole bunch of other libraries. Now, this is not intended to be comprehensive by any means. In fact, nothing I say in this talk is intended to be a comprehensive thing. It's just intended to point out some valuable aspects of the community. Actually, if you draw a line through this image, you will see that on the right-hand side, we actually have libraries and things that are sort of geared towards the functional programming crowd. And on the left side, we have the object-oriented or more traditional software kind of crowd, right? So this is the state of things as they are. What this actually means for us is the Scala community is already bifurcated, right? It's already in a way divided in two. And the crucial point here is that we don't seem to have a schism. We've managed to kind of include both these very diverse and sometimes borderline conflicting groups within the same community. And we have a diverse crowd of people. And in order to actually deal with that, we have some specialized sub-communities. So for functional programming, I think type level is kind of the canonical example of what you might consider a sub-community. There are other sub-communities, right? If you're doing data science or large-scale data research, you might be using Spark or Scalding. So we have specialized communities within the overall Scala community that deal with different concerns. And then we also have specialized events. So whereas Scala Days is a sort of general purpose Scala-oriented conference, you might have FlatMap in Oslo, which is strictly a functional programming oriented conference. Or you might have Lambda World, which I've never been to, but it's also kind of an FP-oriented conference. So, taking this into account, in fact, if you look at it carefully, you see that there's a lot of benefits to having this divide or bifurcation within the community, right? It means that we can tackle diverse use cases. I can't imagine another language being as effective as Scala well, certainly others could be, but Scala is kind of unique in that the ecosystem contains things that include things like Kafka, which is sort of a low-level data store for various things. And then you have Spark, which is a data science platform, or data streaming platform, if you will. So we have very diverse use cases within the community. We also have cross-pollination, by which I mean that members from like one side of the divide and, can make use of and learn from and teach members of the other side of the divide. One example would be Spex2. Spex2 is not very opinionated about how you use it. Spex2 has been used to, to test everything from libraries, functional style code, object-oriented style code. We use Spex2 very heavily at my company at Wix, and we have about 120 Scala developers, very few of which identify themselves as functional programming, and they still use the library. Spex2 uses Scala-z internally under the hood. It's not visible through the API. So because the author of Spex2 has chosen for his own reasons to reap the benefits of a functional style library like Scala-z, we're all enjoying the fruits of the labor on either side of the divide. Also, there's a lot of opportunity to learn and teach. I know a lot more about functional programming than I did, 6, 7 years ago when I just started in Scala. I don't consider myself a functional programmer, but still, there's plenty to learn. There's a lot of people who are very capable and very happy to teach others, and also vice versa. So you might have generic programming. We have Miles in the audience here who's been kind of teaching people how to think about types as isomorphisms to other types and how to deal with them at the type level. That's pretty cool, right? There's a lot of teaching opportunities. So in effect, having a bifurcated community means we get the best of both worlds, right? They're like groups on either side of the divide happily coexist with one another. They might be confused by one another, but there is no inherent conflict here. And we get to enjoy the benefits and the fruits of having all of these diverse groups of people working within the same ecosystem, within the same language. So I think that is actually a good thing. Now, if we take a second look at the same set of libraries, we will be able to draw a second dimension, second axis around which the ecosystem is bifurcated. So, if we take the horizontal line here, at the top we have libraries and tools that are sort of geared towards library authors. Now, this is just my opinion. Some of these library authors may or may not agree with my assessments here. But I would say that Akka, for instance, is a toolkit for developing higher order abstractions. Akka is pretty low level. So on the bottom side of the divide, on the other hand, you have what I like to call your blue collar sort of software developers, your everyday, 9 to 5 software engineers that just want to come in, be productive, enjoy the sort of tools, enjoy the benefits of the Scala and its ecosystem, but are not intrinsically interested in Scala as a programming language in of itself. And those are, that is a very large part of our community. And I think that's a good thing. So these types of developers might prefer to use higher order abstractions, such as Akka streams, and not necessarily use Akka directly. So I would argue that Akka is one example of a library that is geared towards library authors and not necessarily towards end users. But then at the bottom of it, you have other types of libraries that are definitely geared towards end user, towards end users for use in their production systems. So you have Scala JDBC. You can use Spex2 actually on either side of the divide. You have Monix, which is, it might be useful for building libraries, but it's definitely more useful for end users. And that's irrespective of the functional or object-oriented style of these libraries. So you actually have many different axes of division or bifurcation within the Scala ecosystem, and I would argue that that is a good thing. But more crucially, this also causes some challenges. So between kind of the functional programming and OO groups within the Scala ecosystem, there's cross-pollination, but there's a very distinct kind of separation between kind of library authors or people intrinsically interested in language and people who are sort of everyday blue-collar software developers, and I would argue that most Scala users, not necessarily aficionados, but users, are of that group. This kind of division actually causes some challenges. And in the rest of this talk, I wanna cover or give you a quick overview of what these challenges are and possibly what we can do to solve them, or what the state of the art is that allows us to solve these issues. So, I have spent a fair bit of time over the last couple of months talking to Scala practitioners, people within my company, people within other companies in my home country of Israel, people I know personally, and that I can more or less trust what they have to say. I've spoken to probably in the range of 30 to 50 people and asked them a very simple question. You've been using Scala for a while, right? And you do this as your everyday job kind of thing. You just want to be productive. What makes it hard for you? And I've gotten a very wide range of responses, but I've tried to distill kind of the more common ones or the more egregious issues into a set of things that I can actually tackle in this talk. So to start with a bit of a warm-up exercise, one of the things that come up very, very often, especially for new practitioners coming into Scala, is that there's just too many ways of doing the same thing. I'm going to give you a few examples. We're probably going to cover this quickly because this is sort of not all that interesting. For instance, with Lambda syntax, right? You have these 6 versions of the same function that does the same thing. Scala is very, very, it's a pretty sophisticated language, and it's very, very flexible in terms of syntax and feature set. But what this means in practice is that you have 6 different, completely equivalent ways of doing the same very simple thing, right? And this is a problem for new practitioners because coming into Scala, they need to make a decision. They're going to be writing this code. They're going to have to decide which of these 6 ways is appropriate for whatever context they're working in. That is an issue for these people. Also, you have your infix notation versus dotted, or dot-free versus dotted syntax. So if we create a sequence with a couple of strings and we want to filter out only the members that begin with a G, there are 2 completely equivalent semantically and even syntactically ways of doing this. One is with dots, one is without dots. And I keep running into the same kind of questions. Which of these is appropriate for any given situation? There is no clear right answer here. That is the point. Scala is not very opinionated. It just gives you all these tools to play with, and you as a user have to make the determination which of these is preferable. Another example, for comprehensions versus just pipelining operations. So we have 2, once again, semantically and roughly syntactically equivalent versions, right? The generated code from the for comprehension is not entirely, but almost identical to the handwritten version below. And there's not a clear winner. It's an aesthetic preference, right? But if you're actually working in Scala, then you will eventually run into both, and then you will eventually have to make the decision which of these you should be using, right? Like I said, no clear winner. It's a preference, but you still have to make the determination, and that tends to make it hard for new practitioners. Final example, one pet peeve of mine that drives me crazy. I have an issue with fold over options. It just feels very unnatural to me. I know that it's, once again, an aesthetic preference. Both of these versions are completely equivalent. Both are semantically equivalent and fairly readable. But this is yet another decision that new practitioners have to make. Do I use map.getterElse or do I use fold? I don't know. Which one is preferable to you, right? So all of these questions tend to come up over and over and over again, especially for people coming into Scala for the first time. People who have been using Scala for an extended length of time, a few months, tend to develop these aesthetic preferences and sort of converge on their own style of using Scala. But this is a problem for people just coming into the ecosystem. Right, this is a simple kind of warm-up example of the sort of problems that people face when just trying to get into Scala for the first time as once again, as blue-collar, everyday software developers. Let's take a look at some more critical issues. Implicits. Implicits are core to Scala. It's an incredibly powerful feature, but it's also very abstract, right? There's many different use cases for implicits, and fundamentally, for most of these use cases, implicits are kind of very hard to use, very easy to use. Looking at the call site, it's almost transparent, right? Usually you don't see them at play. But if you actually dig deeper and try to figure out what is going on under the hood, implicits tend to be very hard for people to understand and reason about. And I'm going to give two examples of this. So, the first example is the ever-present and very, very scary can build from. Anyone who's used Scala for more than, say, a month has run into this at one point or another. And can build from is hell on earth, right? It's a very, very easy concept to understand. Like if someone came in and explained to you what it's kind of used for, it's very easy to understand why it's necessary. But it's very, very hard to figure out what is going on, even for relatively seasoned veterans. At the call site, it's actually almost transparent. So one kind of canonical example is if you have a bit set with a couple of elements, and you map it through two different functions. If you just take every element and multiply it by 2, you get back a bit set. If you take every element and you map it into a string, because a string inherently cannot be a member of a bit set, that just makes no sense, then it gets transformed into a sorted set, right? So cognitively, that makes sense, but technically, in the way that it's actually implemented in the language, that is very hard to grok. So whereas the call side is almost transparent, if you actually take a look at the signature of the map function, so a person coming into the Scala language who's not a language aficionado would look at this and say, okay, well, I have the mapping function, so that kind of makes sense, but what is this can build from thing? And then, if we're lucky, they start digging in, and even if they have a good notion, good intuition around what can build from is about and what it's used for, they're still going to run into this repr type parameter, and then generally all bets are off, right? As soon as you run into this, you're going to go, what? And then you're probably just going to close the code. Oops, sorry. You're generally probably just going to close the code and stop looking at it and think that there's a lot of dark magic going on under the hood if you use Scala. And that is an experience that I've actually kind of heard about from a lot of different people, and that, for us as a community, is kind of a problem. Second example, John Pretty mentioned Rapture.io as sort of a playground library. I don't know that I'd define it like that, but it has some really, really, really smart ideas on how to model code. One of these ideas is modes. So modes give you configurable behavior on your return type, and they give you type-safe results. So the default mode would be transparently kind of what most people coming in from more traditional languages like Java or C# would expect. I run a parse or an extraction on JSON. If it failed, I get back an exception. That is sort of the traditionally expected behavior. The nice thing about Rapture is it allows you to actually import a different mode of operation, as in this example with return either, and then instead of throwing an exception, it just gives you back an either with a right of, a right fork giving you the actual result of your computation, and if you get a left, then it contains an exception, and you can actually match on top of that. That is a very, very, very smart piece of API engineering. But once again, if you actually go to definition, you actually look at the signature, then you have your data type trait, and then you have your as method, and you can kind of make sense of some of it. So the extractor is the thing that's basically responsible for deserializing stuff out of the JSON data type. But then even for relatively seasoned Scala developers, you see that there's an implicit parameter called mode. And a more experienced Scala developer would say, well, of course it's implicit, right? That is fundamentally what modes are about. But there's also this really weird type parameter where if you're not relatively hardcore in your, if you're not a language aficionado and you don't try to deep dive into how Rapture is structured and what kind of Scala features it leverages to actually provide you with this API, you're going to be very confused about that. And also there's this ext.throws thing where, once again, if you're not very experienced in the Scala ecosystem and in designing libraries, this just looks incredibly confusing. So this is a problem for people coming in and just trying to get their work done. That's it for implicits. By the way, I'm sorry, I had not mentioned, if there are any questions at any point, just raise your hand and I'll pause and we can have them. Or you can save them up for later, whatever you feel like. So, macros. Macros are crazy powerful, right? You can do a lot of different things with macros. Black box macros, which for those of you who haven't run into this concept, are basically macros where the entire signature and the resulting type of the macro invocation is known ahead of time. That's relatively trivial. White box macros, though, which are macros where the result of the transformation of your code, the type of that result is not known statically and ahead of time, are very hard to reason about, and crucially, they're also kind of impossible for IDEs to reason about. So if we look at this code example, and this might seem that I'm knocking on Rapture, that is not my intention. Rapture is a very interesting library with a lot of very good ideas. That is not the point. The point is to exemplify the fact that if you actually try to use that within an IDE, and let's face it, most people coming in and doing everyday software development are not very likely to use shall we say, unusual or kind of Unix-oriented IDEs. They're not going to use Enzyme or whatever. They're probably going to use Scala IDE with Eclipse or IntelliJ IDEA. So this is going to be their experience, right? And if we take a quick look at this example, you'll see that IDEA can't tell that these imports are actually in use, so it marks them as redundant, and that would mean that a non-experienced developer would just go on in, click on optimize imports, and all these imports go away, even though they are in use. And crucially also, this slurp function is just not recognized. And the reason for that is that IntelliJ, and to my knowledge, Scala IDE, I don't actually use Scala IDE day to day, so I'm sorry if I'm assuming things that I shouldn't be. But if you look at what the resulting type of Scala site is, as far as IntelliJ IDEA is concerned, it's any, right? It doesn't actually know what the type is because it's the result of a white box macro invocation. And that actually happens in practice more often than not until people actually learn to avoid libraries that make use of white box macros in their everyday job. That is still kind of a problem. DSLs. DSLs are considered to be a killer feature of Scala. Some people love them, some people really, really don't. That is fine, but it's still a very big selling point for a lot of people coming into Scala from more traditional languages. Once again, Java and C# come to mind. DSLs have some inherent issues in Scala. One issue is around documentation. So ScalaDoc is busted. ScalaDoc doesn't work right. And I'm going to circle back to ScalaDoc in a little bit. We're basically down to user guides. So if you use any meaningful Scala library, be it ScalaTest, Spex2, Spray, whatever, pretty much any language library that features a domain-specific language, you're basically down to using user guides to figure out what is going on and how to use these libraries. This is a bit of a problem because user guides are fundamentally ad hoc, right? There is no standardized and formal way of defining of writing user guides. It's just text and markup. You can do anything you like with it. So that tends to cause people some issues around discovering the user guides and reading through them and finding the right sort of material. Speaking of discoverability, DSLs actually have a real issue in Scala because autocompletion, which is sort of bread and butter to everyday software developers like myself, autocompletion doesn't work right with DSLs. because there is nothing to tell the IDE where to go and what things to prefer, what things to show you in this auto-completion list. So once again, you're basically down to sifting through incomplete and sometimes outdated user guides that are very, very hard to navigate and very hard to find what it is that you're actually interested in for a particular library. And that is a problem. Now, circling back to ScalaDoc. ScalaDoc is very badly documented, and it's kind of ironic that a documentation tool is badly documented. Just doing a quick Google search for ScalaDoc documentation will get you 3 kind of canonical sources of information about ScalaDoc, and a lot of questions and a lot of rants about ScalaDoc. None of these guides is comprehensive. None of these guides is, in my experience, particularly useful. They're conflicting. Some of them are dated. It's not even clear which one you should be reading. Also, there's some syntactic issues with ScalaDoc. Like, regardless whether or not you approve of like custom markup within basically inline code comments, even for really, really fundamental things, such as linking to methods or linking to types, there's a lot of confusion. Basically, the guides will not give you the information you need to properly link to things. So, you wind up just trying stuff out, and that is both time-consuming and frustrating, and in my experience, it doesn't work. I spent about a week trying to add like comprehensive ScalaDoc-based documentation to my own library, which is called Accord, only to eventually give up in frustration and just move on. ScalaDoc is not very useful as it stands. Also, it's not very well supported by IDEs. So Scala IDE actually tends to be a bit better in rendering ScalaDoc than IntelliJ IDEA is, but in either case, these are very kind of incomplete ad hoc solutions to a problem. Whereas if you came from the Java space, Java docs are actually, well, maybe annoying, but very, very useful, right? You can actually get your work done properly with them. ScalaDoc doesn't fit the bill. Right, so these are the common themes, the common challenges that I've run into when discussing this with people coming into the ecosystem from a more traditional software development background. Let's have a look at what we can do about it, right? What is the state of the art that allows us to actually deal with these issues? So with respect to language concerns, such as too many ways of doing the same thing, or different syntactic preferences and such, there's actually plenty of tools you can use. So if you just want a prescriptive thing to tell you what to do and where to do it, you can use a style guide. You might use Twitter's, you might use Databricks'. I'm pretty sure there are others out there, but these are kind of the 2 most well-known ones. I personally dislike style guides. I hate being told what to do, but a lot of companies that I've spoken to over the last few years, this question consistently pops up, right? What is the canonical style for Scala code? And if there isn't one, what are 1 or 2 options we can actually pick from in order to know how to style our code? So nowadays, you actually have pretty in-depth style guides that you can build on if that is kind of your bag. Code formatting, which is kind of the dual of style guides. We used to only have Scalariform. Now we also have Scala format, which, if I'm not mistaken, is based on Scala Meta. Those are actually pretty powerful tools and are used to good effect. Once again, I have an issue with my code being reformatted automatically by tools, but that is just a preference. If you need these tools, if you want to enforce consistent Scala style in your project or your organization, nowadays you actually have the tools in place to do this pretty reliably. And with respect to do's and don'ts, like should you use option.fold or option.map.get or else, and various other kind of constructs that you might run into, you might want to enforce these or at least warn about misuse of these things with static analysis or lint tools. So you have 3 tools in the Scala space. You have more than 3 really, but you have 3 kind of maintained and from my research, actually workable tools in the Scala space. Those are Scapegoat, Wart Remover, and ScalaFix. ScalaFix is fairly new, but it's developing pretty rapidly. The other two actually offer a large collection of rules. So if anyone remembers the back maybe 10 years ago in the .NET days, we had FXCop for the same purpose. It's basically an enforcement tool, right? If you have many developers and you want to make sure they use a consistent semantic style of coding as opposed to just formatting, then these tools can help you enforce that, or at least point out inconsistencies in your code base. Those are actually very powerful tools. In other words, there's been a lot of progress on this. Scala used to be kind of the new kid on the block with a lot of these tools kind of missing from the ecosystem. That is no longer the case. Nowadays, we actually have very powerful tools to help us work through these things. With respect to documentation, it turns out that we actually need two separate and completing like dual types of documentation. In my experience, generally on an everyday basis, you need both. You need the inline documentation, as with ScalaDoc. It doesn't necessarily have to be inline, but that tends to promote kind of better maintenance of these documentation blocks. ScalaDoc is, or a tool like ScalaDoc, the tool that we would like to have would be formal and very well defined. And it focuses on clarity and discovery. So this sort of thing would allow for IDE integration. It'll allow the IDE to actually show you signatures and point you in the right direction and just quickly kind of look up documentation for APIs. We definitely need that. Most Scala libraries nowadays tend to not have that, and this causes no end of headaches to sort of your everyday blue-collar practitioners, sorry. We also need external documentation because ScalaDoc is not enough. Same as JavaDoc is not enough. You will notice for any major Java or C# or like basically any library in any statically typed language that you tend to have both. You tend to have the formal kind of signature-oriented documentation like JavaDoc or ScalaDoc, and then you have your user guides because people coming into your library need to have like an entry point. They need to have prescriptive advice on how to use your library, what it's good for, what use cases it aims to solve, how to use it effectively, do's and don'ts, examples, right? All of these things do not lend well to ScalaDoc type documentation. So you actually need both of these things. For inline documentation, ScalaDoc is actually almost good enough. Like it has a bunch of issues, and I'm not a big fan of ScalaDoc, but it does almost work. Also, as it turns out, there's just no real alternative that I could find in like a quick research session. Some things have to be improved in ScalaDoc in order for it to be an effective tool within the Scala community. So documentation obviously has to improve remarkably, and it's very easy for me to say this, and like the harder thing for me to do would be to pick it up and start writing these documentations. I'm hoping to actually do that. I'm not going to promise anything. I don't know for a fact that I can keep. But there is need for better documentation on ScalaDoc and its syntax and prescriptive advice on how to use it effectively. Also, IDE integration must be improved. So it's rendering and rendering speed and lookup and consistent application of ScalaDoc rules. All of these things need to improve for ScalaDoc to be a meaningful tool for Scala users. ScalaDoc did get one thing very much right, though, and I don't think people appreciate this enough. There is a use case annotation in ScalaDoc where you can take something like the map function and actually provide a simplified kind of use case-oriented view of the signature for that function. So, software developers who are actually going to go into that function and try to look up the signature and look up the documentation for it will first see the simplified version, which doesn't have anything to do with can build from. It's pretty straightforward. It just gives you the gist of what it is and how to use the function. And then at the bottom there, you have this full signature thing, where if you click it, it actually opens up the full-blown signature for the function, including all the low-level implementation details of how it's actually, how these constraints are encoded in the language. Right? This actually, this is a bit ugly, and I used to think it's a very hacky way of doing things. But in my experience, this actually solves the problem for most users. People who actually end up looking at the documentation tend to really appreciate this because it makes life easier. So this seems to actually solve some of the complexity problem around documenting kind of more, shall we say, higher order Scala features as used in libraries. Also, just one quick note, can build from is probably going away. There's a whole effort around re-architecting the Scala collection library for, I think, Scala 2.13, but it might, it might take a while before that kind of reaches production grade. So can build from specifically is going to go away, but there's plenty other examples in the same category that are not going away anytime soon. So this actually solves the problem nicely. So, assuming we have a decent tool chain for internal documentation, for inline documentation, let's take a look at external documentation. What do we actually want from the tools that allow us to author and consume external documentation? Well, ideally, what we'd want is we'd want some kind of templated thing. Like we don't want to have to worry about HTML and CSS, or even the fact that it's going to be rendered into HTML and CSS. We want to speak a higher language, a higher set of abstractions. So some sort of template engine built into the tool is pretty much a must. We want the documentation to be type checked. Right, one of the issues with documentation, and definitely user guide style of documentation, is that it's very easy to forget to update it when you've changed your code, when you've added features. Scala is unusual in my experience in that it actually has some tools that allow you to generate documentation in a type-checked way. So actually, as part of your build process of your library, you will have a build step that actually verifies that your code samples within your documentation pretty much match reality, right? And finally, because we're talking about user guides, we also need arbitrary markup. And it turns out that unlike almost any other software community I've ever been a member of, in the Scala community, it turns out we actually can have nice things. So there are kind of three tools that I want to point out. Once again, this is not a comprehensive list. There are many ways of doing this. But there are three modern and well-designed, I feel, tools for actually producing this type of documentation. All of these tools support templating. All of these tools support arbitrary markup. There are differences in the approach. My favorite among these tools so far seems to be Tut from Type Level. And you might just use like GitHub Pages and write your documentation in Markdown with Jekyll. That is actually a workable solution. My own library uses that. But ideally, I will, in the near future, actually move to one of these other two tools, probably Tut, whatever. Probably move to one of these other tools because I want to make sure that my documentation contains code that is type-checked and that is correct. And that is a huge boon because that means no more outdated documentation, right? The documentation cannot be updated because if it's incorrect with respect to the code, I'm not talking about text, I'm talking about like code samples and such. If it's incorrect with respect to the code, well then, it's not going to compile, right? So that is actually a very, very nice feature to have. And I've not run into this in any other language, although I'm pretty confident that it exists in many other languages. Some ideas that are actually not out there yet. So DSLs are still a problem. So if we take a look at this very, very artificial and simplified example of a validation API, you might have this extension, this implicit class that provides an extension method. So the idea is that you'll be able to write assertions or validation assertions in a nice syntactic way. Something like, my input string is equal to some expected string. The problem here is discoverability. And I think maybe there's room for improvement here with some sort of hint system that might tell the IDE where to search for appropriate possibilities in its auto-completion algorithm. Right? This is not really well thought out. I'm still kind of prototyping a very simple version of this to see if it makes any sense. But it's an idea, right? So I'm pretty sure that there's some stuff we can do to actually help IDEs constrain completions and provide a better user experience to people actually working with libraries based off of DSLs. Finally, IDEs, not quite finally, but almost finally. IDEs still, like Scala IDEs tend to still have a number of issues. Performance is a critical issue, but there's a lot of efforts being done to remedy that. Crucially though, from a feature set perspective, there's still a very limited support in both IDEs, in my experience, for both macros and refactoring. Now macros, especially white box macros, as explained, are problematic, right? It's not something the IDE can reason about. And refactoring tends to be very hard because refactoring Scala code from strictly an implementation and technical standpoint tends to be harder than refactoring kind of more traditional languages like Java. There is a framework by Eugene Burmako and friends called Scala Meta, which might actually help a little bit. So this is actually a year-old post from the IntelliJ IDEA team about how they're trying to integrate with Scala Meta to provide some nice features such as macro expansions and possibly in the future better refactoring. Scala Meta might be a good kind of underlying tool for this. So there's definitely a ways to go, but the state of the art is that the kind of bare bones tools necessary to actually work through these issues and provide a better user experience is in the works, and there's a lot of very smart people working very hard to solve these problems. So this problem will go away soon enough. And finally, we have the social element. So if we want to have an inclusive community, and by inclusive I mean across the board, but in this case I'm talking about a community that caters to both the people coming into Scala because they're really, really interested in the language as a language, and they're really looking to push the boundary and exploit whatever the language offers them. And we also want to cater to everyday software developers who just want to get their work done and be productive and be effective and get paid for less work with less bugs and go back home to the wife and kids. That is fine. We want to cater to all of these groups. So in order to do that, we basically need to have two things in place. The first is, I'm actually going to start at the bottom here. The first thing we need to do is to acknowledge these preferences, is to acknowledge the fact that we have these diverse groups of people within our community and just be respectful. Right? It's fine if someone comes in and wants to use a library and doesn't want to go through the hoops of learning everything there is to know about implicit search scope and implicit recursive resolution and what type classes are. It's okay. They're probably going to learn it by osmosis sooner or later anyway, but we don't have to force them to learn these things just to use our libraries. So as library authors, the functional programming community actually tends to be better about being explicit about its preferences. So if you look at CATS or Algebra or a lot of these kind of FP-oriented libraries, they make it very explicit from the go that they're a pure functional style libraries designed for pure functional style software. And I think we should be a bit more explicit about this in kind of the other side of the fence with respect to what our intended audiences are. Also, as library authors, and this is actually a huge pain point in the Scala community, and I hope it's going to slowly improve. If you look at any 9 out of 10 random libraries on GitHub, you're actually not going to see a lot of docs. You're not going to see Scala docs at all. You're going to see a very limited user guide. Only the big libraries tend to invest a lot of time and effort in having like comprehensive and expansive user guides. So we need to be better at this as library authors. And that is pretty much the only thing that will get people to actually enjoy the benefits of Scala and not just use it as a better Java, as most people tend to coming into the Scala ecosystem. So this has been an overview of kind of challenges that people coming into the community from a less language aficionado style background tend to face, and a little bit about the solutions. This is pretty much all I have for you. So thank you very much for your time. I hope this has been somewhat useful. I don't know if we have time for questions, but if not, then you're more than welcome to find me afterwards. And please remember to rate this session, because this is Scala Days in Copenhagen. Thank you very much.
Hi, thanks for the talk. It's more of a comment, but what I see is that if you're not coming from Java, you actually have the problem that you have to learn Java as well, kind of, because you have libraries like, or it's like Kafka or whatever, or also Lagom from Lightband is now starting with Java. So if you want to get into that, you have to learn both sides. And for somebody, let's say, coming from Ruby, this simpler side of Java and everything can be quite appealing, and you can get the impression that Scala is kind of a more influx and unstable thing on top of a more stable Java ecosystem. I would say that's kind of impression I had with talks of people coming from Ruby, for example. And I think that's also a main issue in the Scala community, and you will have kind of a burn of people, turning their back to Scala because of that and say, okay, we can just use Java instead. And also maybe it was kind of bitterness because of all of the black magic and things they didn't understand and then going away. Maybe I could hear your take on that.
Okay, so there's two aspects of your comment that I want to touch on. First of all, an observation. It has actually been my experience that people coming to Scala from a Ruby background, specifically Ruby, actually tend to have an easier time than people coming in from a Java background. I'm not sure why that is, by the way, but I've had conversations with a number of previously Ruby developers, and they said that Scala actually, like, it seems like a very straightforward kind of paradigm shift for them. I would argue with that statement where if you're coming into Scala, you actually have to learn Java. You have to learn a bit about the JVM, because sooner or later you're going to run into one of the, not that many, but one of the different ways in which Scala is somewhat limited by being hosted on the JVM, such as type erasure. You don't really have to learn Java because pretty much any Java library is exposed to Scala natively, right? Scala code that uses a Java library and Scala code that uses a Scala library don't tend to look very different up to certain interop aspects like handling nulls. So I'm not entirely sure where, I'm not dismissing your experience, certainly, but I'm not, like, I can't really imagine what process actually got you to thinking that you have to learn Java. So I can't really comment that much on that, unfortunately. But the thing I can comment on is people coming into Scala, looking at Java, saying, okay, Java gives me what I want, certainly Java 8 gives me what I want, and then basically ditching the more in flux, as you say, ecosystem of Scala in favor of Java. My comment to that is in two parts. First of all, Scala is infinitely more powerful than Java 8, and I actually have a completely separate hour-long talk exactly about that. So even for everyday kind of things, without going into any functional programming or without talking about macros or any of the sort of Scala specific features, there are still many advantages for an everyday developer using Scala instead of Java 8. If you're interested, I can share with you some of those later. But also, I think some of the people who get frustrated with Scala and then end up looking for simpler ecosystem or simpler languages, a lot of the time it's because of one of the issues that I've covered in this talk. So if we can mitigate some of these, if we can eliminate some of these gaps, if we can find ways of making the Scala community just a bit more approachable, I think that problem will largely go away on its own. So I don't know if that is the kind of comment you're hoping for. If not, please feel free. Like I'm around. We can discuss this until midnight if you like. Okay, I'm pretty sure we're smack out of time. If anyone has any other questions or comments, please feel free to approach me at any point. Thank you very much for your time and enjoy the conference. Cheers.